Okay, so tangent line and normal line to the graph of f at point A and f of A. So there's parentheses that are missing, so they're really saying A and f of A. That's what they're really saying. And then they give you the A, which is 7. And of course, you got to find the f of A. And they give you the function f of x, and that is rad x minus 3. So what does the y value turn into then? 2. So we found the y value. So what else do we need to find the equation of a line? Slope. Okay, we have point now, so we need slope. To find the slope, we have a special word. What's the word for slope? Derivative. There we go. Okay, like I said, if you have no clue what to do in this class, take a derivative. Okay, that's 1/2 x minus 3 is equal to negative 1/2 times 1. I'll use chain rule just to show you that I'm still using chain rule. If you clean this up, that's 1 over 2 times rad x minus 3. That's what that is. Okay, this is the slope of this curve at any point. Okay, but we're looking for the slope of this curve at a specific point at x is equal to what? 7. So when you do that, you're going to get 1 over 2 times 2, which is going to give you 1/4. Now you have the slope, you have a point. What's the equation of a tangent line? Y minus 2 1/4 x minus 7. And for those of you that are nostalgic about y is equal to mx plus b, okay, you still have a lot of work to do. Okay, so that's why y is equal to mx plus b is not really a very efficient way of finding the equation of a tangent line. Now, what about the perpendicular line? Well, if this is the slope, if the slope is 1/4, but what is the perpendicular slope will look like? -4. So the equation of a normal line will be y minus 2 is equal to -4 x minus 7, and then you are done. Alright, so let's go to 3. Number 3, section 8. Okay, it says derivative of the function f of x. So they give you f of x is equal to x squared plus 1. And they were even kind. They said f prime of x is equal to 2x. Well, find the equation of a tangent line at the point 1, 2. And then sketch the graph of the f and the graph of the tangent line and normal lines to the and normal line. Okay, so we're doing the same thing, but they already did the derivative for you. So how do you find the slope then? F prime of what? 1. So my m turns out to be 2. So what about the perpendicular slope? What will that be? So what is the equation of a tangent line then? Y is equal to y minus, excuse me. I violated my own. Y minus what? Y minus 2 is equal to 2 times x. Okay, we're going to graph this, so we might as well just now put it in the point slope-intercept form. Yes. Calculator for what? How many times did I use a calculator just now? Bring your organic calculator. That's the most important thing. Okay? Alright. So, this is y minus 2 is equal to 2x minus 2. So y is equal to 2x. I did that because I'm going to graph it. It's just easier for me to graph it this way. Okay? Teresa, I'm over here. Lobe knot's not going to help you. She doesn't know what she's doing right now. Look at her last quiz grade. Okay. She keeps saying she got this. You don't got this. Okay. Y minus 2 is equal to negative 1/2 x minus 1. Multiply this out. Y minus 2 is equal to negative 1/2 plus 1/2. And then this is going to give me y is equal to negative 1/2 x. Negative 1/2 x. Okay, and when you take that over, that becomes what? 2 and 1/2, right? Okay, which is same as 5/2, correct? Alright, so I'm going to graph this line and this line, and I'm going to graph this curve. Okay, so here it is. What kind of a graph are you going to get when you graph this parabola? Which way does it open? Okay, the y-intercept, the vertex is 0, 1. It's just a parabola that's moved up by 1. So it's going to do that. When x is equal to 1, y is equal to what? When x is equal to 1, y is equal to 2. So we're looking at this point right there. The tangent line to the graph, which is going to look like that. That's going to be y is equal to 2x. Does that make sense? Okay, the perpendicular line, the normal line, will look like that. And the equation of that is y is equal to negative 1/2 x plus 5x. And there it is. That's the point. Alright. So that's it for section 8. So let's get to section 9. Tyler. 2. What else? Nathan. 7. Ivan. Irvin. 8. Six. Did you even attempt any of these things yet? Okay, good. That's a start. Working on it. Want to run with the big dogs, but don't want to run. Number 2. Okay, this is number 2. You're given f of x is equal to 2x when x is less than 1, and then you're given 2 when x is greater than or equal to 1, and they're asking you, is f differentiable? Is f differentiable at x is equal to 1? And this type of question shows up on AP test and pre-response. So you need to show all of this work I'm about to do. First of all, to check and see if differentiable, okay, it is necessary the function to be continuous, but not necessarily sufficient, okay, for it to be differentiable. So that means you must first prove this function is continuous at 1. And how do we prove if the function is continuous at 1? You use limits. First of all, you take a limit as x goes to 1. Okay, from the left side, which one am I using now? Top or the bottom? Top. So 2x, what's the limit of that? 2. So far, so good. Then we take a limit as x goes to 1 from the right side. Which one do I use for that? Bottom one. And what does that limit turn out to be? 2. That means we know the curve goes to 2, whether it's coming from left or right. But now we've got to check and see if there's a hole there. Because if there's a hole there, it's not continuous. How do you check for that? You actually find f of 1. Which one do you use for that? Bottom, which turns out to be 2. Look, we have a match. What does this mean? means f of x is continuous at x is equal to 1. Now, if we didn't have a match, automatically we can say now it's not differentiable. Okay, but you got to establish that match first. Okay, now we're going to check and see if it's differentiable, means if the slope exists there. To do that, we are going to take a derivative of this function. What's the derivative of this? 0. Okay, no, it's not 0. Why do I listen to you? It is 2. Okay, what's the derivative of that? 0. When x is less than 1, okay, when x is greater than or equal to 1. You can already see the slopes are going to be different without even doing any work, but you don't get any credit for that. You have to go through the whole process again. Okay, so we're going to take a limit as x goes to 1 from the left side of f prime of x. That's what we're taking limit of. Okay, which one do you use for that? Top one. Okay, and that turns into, I don't want to be redundant. So what does that turn into when you use the top one? 2. Okay, so that turns into 2. Okay, then we're going to take a limit as x goes to 1 from the right side of f prime of x. What does that turn into? 0. We don't have a match. As soon as we don't have a match, then we know it's not differentiable there. Okay, slopes have to be the same. Slopes are different. Okay, now if we need to have a match, we still have to go back and plug in the value at f prime. Okay, so we say f of x is not differentiable at x is equal to 1, and that is what you have to show on the free response question. All that. Okay. So in a nutshell, continuity is a necessary condition for differentiability, but not necessarily a sufficient condition for differentiability. Does that make sense? Okay. Yes. Graph this one? Did they ask me to graph it? Yeah, sure. Okay. I'll graph this one. What kind of a line do you get there? A straight line. Very good. All lines are straight. Okay. 0 is my y-intercept, and it goes up. Slope is 2 over 1. Okay. So I have a line that has a positive slope, right? Okay. To the left of 1. So that means this line doesn't exist to the right of 1. So it looks like that. It looks like that. So far. Okay, what kind of a line do I get? I know it's a straight line. Okay. What kind of line do I get for this one? Huh? All lines are straight. Thank you. Okay, it's a horizontal line, but we're including at 1 it's equal to 2. That means it's going to fill it in, and it's going to go to the right. Look, we have a corner here. When there's a corner, the slopes are different. That means it's not differentiable at corners. Okay, anytime you have a corner, it's not differentiable. So if you like have a parabola, and then you have a line, this is differentiable everywhere except there. But it's continuous there, but it's not differentiable. Can't find the slope. Okay? Alright. So, that's number 2. Alright, let's go to the next one then. Next one is 6. Let's do 6. Let's see what 6 is. 6. Find the points where the tangent line to the graph of f of x is equal to 1/3 x to the third plus 1/2 x squared minus 2x plus 10. Okay, it has horizontal tangents. Horizontal tangents meaning flat spots for the curve. What kind of a slope do you have when there's a flat spot on a curve? Zero slope. Zero slope. So that means we're trying to find out where the slope of this curve is 0. First, we've got to find the slope. How do you find the slope of this curve? Okay, you know, before this year, you can only find slopes of lines. Now you can find slope of any curve. Just take a derivative. Okay. Yeah. All right. Take derivative of that, which is x squared. Take derivative of that, which is x. Take derivative of that, which is -2. Take derivative of that, that is 0. Okay, that is the derivative. That is the slope of this curve. We want to find where the slope is 0. Are you still with me there, Jessica? All right. Slope is 0. All right. So we're going to set that equal to 0, and we're going to solve. Comes to your algebra skills. How do you solve for this quadratic? Factor. I hope you still don't have to use diamonds and all that nonsense. Killing me. Okay, plus 2 minus 1. That will work. I get x is equal to -2. I get x is equal to 1. Okay, that's where you have flat spots for the curve. Okay, now they said tangent line. Find the points where tangent line. Okay. Oh, they said points. Ooh. I wouldn't give you full credit for that because they said points. These are not points. These are only half of a point. Same thing on the AP test, man. You said points, they got to find the point. If they ask you to find the x value, then you find the x value. Okay. Now we have to put in -2. Where do I put in -2? Original one. -2 here, we'll make that into -8. Okay, that would be -8 over 3. -2 here, we'll make that into a 4 over 2, which is 2. And -2 here makes that into a positive 4 plus 10. Alright, so you got 2 plus 4 plus 10, that's a total of 16. You have -8 over 3 plus 16 over 1. Common denominator is 3, so this turns into 48 minus 8, which is 40 over 3. Alright, what's the next number you're going to put in? 1. 1. 1. So when you put in 1, my f of 1 now turns into 1/3 plus 1/2 minus 2 plus 10. Okay, so this is going to give me 8, and I can do ancient and secret real quick here. That's 2, that's 3, that's 5, 6, okay, plus 8. Common denominator, 6, so what does that turn into? 40, what? 52, okay, 53, yeah. 53 over 6, you're going to kill me here. 53 over 6. Now, you get full credit. Alright, 7A. Hey, Joey, yesterday I misread that problem, so I want to correct this. You asked me this question, and I thought about it. I said, oh, it's not composite, it's just times. That's why. You know, remember yesterday we got no solution for that? Okay, because it's not composite. That's a dot, that's not a circle. Okay? Alright, so let's do 7A. And once you do A, B is easy. So 7A. Okay. 7a, they tell you f times g prime, and this parentheses missing, of 5. That's what that is. Okay, what they're really asking, what they're really telling you is this. You have some function h of x that is f of x times g of x. And they want you to find h prime of 5. That's what they're really asking you when they're telling you all of this. Okay? So, we need to find the derivative of that first. What rule do I use to find the derivative of h prime of x? Product rule. Okay, first times the derivative of the second plus the second times the derivative of the first. H prime of 5 therefore would be f of 5 times g prime of 5 plus g of 5 times f prime of 5. Do they give me a number for f of 5? 1? Can I trust you? Okay. Times. What about g prime of 5? 2. What's g of 5? Negative 3. What's f prime of 5? 6. So this would be 2 minus 18, which is negative 16. So what do you think f over g prime of 5 really means? What do you think this means in B? What are they asking you to do? Use quotient rule. What's my h of x? This is really f of x over g of x. And then what do you have to do to take a derivative of that? Okay, quotient rule. And then after you take a derivative of that, you're going to plug in what number? 5. But what do you think they mean when they write something like this? G over f of 5. What do you think they're telling you now? That h of x is really g of x over f of x. And then they want you to find h prime of 5. Okay, take a derivative. Okay, find evaluate at 5. Take the values they give you, plug them in. Alright, so let's move on to 8. Okay. Number 8. Finding, wow, we're finding another equation of a tangent line. And we've never done anything like this before. That is parallel to this other line. X minus 2y is equal to 1. Okay. They want you to find the equation of a tangent line to that curve, but it's parallel to this line. So if it's parallel, what do you know about the slope of this curve? And then the slope of this line has to be same. How do I find slope of this line right there? Yeah, you can just solve for it. This is a line, so just solve for y. So negative 2y is equal to negative x plus 1 divided by negative 2. So y is equal to 1/2 x plus 1. So what's my slope over here? Of course, for those of you that are really into calculus, you can take the derivative of this implicitly. You'll get the same thing. Yeah. Alright. But, how do we find slope of this curve over here? Derivative. What rule do I have to use to find derivative of this curve? Quotient rule. Denominator, which is x plus 2, times derivative of the numerator, minus the numerator, times the derivative of the denominator, all that over denominator squared. Okay. A lot of you will be, well, yeah, let's go ahead. We need to do that. We do need to simplify this. Okay. This would be x plus 2 minus x all that over x plus 2 quantity squared, and that simplifies to 2 over x plus 2 quantity squared. This is the slope of this curve. If they're parallel, then what do you know this slope and this slope have to be? Same. So we're going to set them equal to each other. So 2 over x plus 2 quantity squared is equal to 1/2. Cross multiply, 4 is equal to x plus 2 quantity squared. Okay, and then solve for x, so you get x plus 2 is equal to plus or minus 2. So my x is equal to negative 2 plus or minus 2. So I get two solutions. Okay, x is equal to negative 2 plus 2, which is 0. And I get x is equal to negative 2 minus 2, which is negative 4. There's two places that happens in that curve. Okay. So I have, right now, I have this. I have 0 comma something, which I don't know what that is. Negative 4 comma something, which I don't know what that is. How do I find the other half of that point? Where do I plug it in? Which one? Very good, because that's where we're trying to find tangent to, that curve. So when I plug in 0, the whole thing turns into 0. That was easy. When I plug in negative 4 right there, the top is negative 4, bottom is negative 2, so negative 4 divided by negative 2 is going to give me positive 2. Positive 2. Alright, so we found the point. The slope is 1/2, both places. Okay. For this one, the equation of that tangent line is y is equal to 1/2 x. That's done. Because that's the y-intercept is 0 anyway. For this one, you're probably better off writing as a point slope form. So it'd be y minus 2 is equal to 1/2 times x plus 4. And that's my second. Alright, last one in this section. Let's look at number 9. So number 9. F of x is equal to x times square root of ax minus 4. Okay, find the equations of any vertical and horizontal tangent lines. Okay, vertical tangent lines are like these. What kind of a slope do you have? Huh? Undefined. Horizontal tangent lines are lines like this. What kind of slope do you have there? 0. So undefined slope we're looking for and a 0 slope. Okay, that's what we're looking for. But this is the function, so how do I find the slope of this function? Derivative. Okay, what type of rule am I using here? Product. First, times root of the second plus the second times root of the first. Cleaned up. X over 2 square root of x minus 4 plus square root of x minus 4. Okay, let's figure out where this derivative is undefined. Where is this derivative undefined? There's one value. It's obvious. It's sticking out right there telling you, hey, can't use that number. What number I can't use here? 4. Okay? So, at 4, it's undefined. So, x is equal to 4 is undefined. Okay? Now, are we finding equations? Yep, we're finding equations. Okay? So, 4 comma something, we need a point. So, how do I find my y value? Plug it in. When I plug in 4 right there, that turns into 0. So 4, 0. So I have a point. 4 comma 0. X is 4. Okay, comma 0. Undefined means I'm going to have a line like that. So how do I write the equation of that line right there? X equal to 4. Right. Let's go to zero slope. Zero slope means I got to set this whole derivative equal to 0. So we need to add these two fractions. This is where the ancient Indian secret comes in really handy. X over 2 square root of x minus 4 plus rad x minus 4 over 1. We're going to multiply, multiply, and multiply. That turns into x plus. Look, when you multiply these two, the radicals disappear. You're going to have 2 times x minus 4. And then when you multiply the bottoms, it'll be 2 times square root of x minus 4. Those of you that like the traditional way of adding and subtracting fractions, find the lowest common denominator and all that, can still do that. You get the same thing. When you clean up the top, you're going to get x, 2x, which is 3x minus 8, is equal to 2 times square root of x minus 4. This is the derivative simplified. Okay, where is this derivative equal to 0? This is the fraction. When is any fraction equal to 0? No, when the top is 0. Okay, top happens to be 3x minus 8 is equal to 0. So x is equal to 8 over 3. Okay, so we only have half a point. Okay, and that is 8 over 3. How do I find the other half of that point? Plug it in. Okay, plug it into where? Okay, so we're finding f of 8 over 3. Okay, put in 8 over 3 there. Okay, so that's 8 over 3 times square root of 8 over 3 minus 4. Okay, you can still use ancient Indian secret here. This is going to be what? 8, and that's going to be what? Well, I don't like that. Okay, 8 minus what? 12? 8 minus 12 over, I'm getting a negative inside the radical, that's why I don't like it. No, we don't deal with i's. Okay. Okay, horizontal tangent of x times square root of x minus 4. Shh. Let me think. This curve only exists to the eighth-third. Okay. Alright, got it. Here we go. Okay, I'm getting a negative inside the radical, right? So what does that mean? That means I don't have any real value, correct? So the graph doesn't even exist there because this is a square root function. I have a domain restriction here. What's my domain right there? What does my x have to be? Greater than or equal to what? 4. Okay. It's got to be greater than or equal to 4, correct? So my curve only exists to the right of 4. But 8/3, what is 8/3? It's not right of 4, is it? Okay, it's left of 4, and that's why I'm getting an imaginary value. That means this one has no horizontal tangents. Okay? No, none. Okay? Alright. So I could have saved myself some time if I found my domain restriction early, and then when I got to here 8/3, I didn't have to go try to find the slope. Okay? So be careful about those. You can save yourself a little bit of time by doing that, finding domain restriction of a function. All right. Section 10. What's that? 4, 3. Any others? 4 and 3. 2. Okay. All right, here you go. Number 2. You have y is equal to x to the 4th plus 2 all that over x. This actually, believe it or not, shows up on the AP test and multiple choice. It is so easy, but some of you who do not know your algebra well will spend and waste a ton of time doing this problem, and then you'll come out of the AP test and then you start talking to each other. You know that problem number 22? Man, it took me such a long time to do that. And the kid next to you says, no, all you have to do is do this and this. Go, oh. Okay? Then you feel stupid. Okay? So this problem is to make you feel stupid, waste a lot of time, so you don't get that 5. So you end up getting a 3. Okay? So, moral of the story is, know your algebra. We're going to third derivative. That means it's going to get ugly and nasty if you're going to take a quotient rule. Even the first derivative is going to get ugly, and then it's going to get even more ugly after that, and then ugly even after that. So you might want to do some algebra. And when you do algebra, this is really I know wheels are turning. Do I have to show you? Do I have to show you? Okay, if your neighbor doesn't know, tell him what I just did if you know. We're good? Okay. We're good? Algebra's good? Alright. Now, that was the hardest part. The derivative is 3x squared minus 2x to the negative 2. Okay. Second derivative is 6x plus 4x to the negative 3. And the third derivative is 6 minus 12x to the negative 4. And you are done. Now, can you imagine doing this using a quotient rule? Okay. Cara, I know you're going to do it. Nah? All right. Three. David, are you comfy back there? Yeah. Alright, 3 shows up on AP test all the time. I'll guarantee you you'll have at least one problem like this. Okay, one problem like 2 and one problem like 3. I can promise you that. So make sure you know what this symbolism means. There are parentheses that are missing, so I'm just putting in those parentheses for you. On the AP test, it won't be like that. Okay, that's what this problem is. Okay, let me explain to you what they're really asking you to do here. Okay? you have to work, this is brackets and parentheses, just like PEMDAS. You have to work from inside out. So first thing you have to do is you have to take a derivative of this function right there and leave everything else alone. So this is d squared dx squared, all that times x to the second minus 3x. And then when we take the derivative of that, that's going to turn into 1 minus x to the negative 2. Any questions? Not yet. Only thing I've done is this part right there. Now this is telling me take a second derivative of this. You can do that. But if you do some algebra, your life will be much easier. Okay? So let's do some algebra before we take the second derivative of that mess. Okay, when you multiply this through, you're going to get x squared, okay, minus x to the 0. Multiply this through, you're going to get negative 3x plus, okay, or minus, not plus, plus 3x to the negative 1. Let's clean it up some more. D squared dx squared. Remember, I keep writing everything all over again. Okay, this is x squared. And what's that, really? 1. Okay, so minus 1. Okay, minus 3x plus 3x to the negative 1. Okay, now, we are taking two derivatives. You can do this in your head, or you can show each step. So what do you want me to do? Show each step? Okay, fine. But if I show each step, then you better show each step on the test too. So don't go around skipping steps on me. Okay, so this is d over dx. Two x minus 3 minus 3 x to the negative 2. So what I just do, took a derivative, and that's why my squares disappeared on the d and the x. Now, it's telling me I have to take another derivative, right? Yeah, that's this part right there, because the square here means the second derivative. So I'm going to get a 2, okay, plus 6x to the negative 3, and then you're done. How you doing, Jessica? Good? Yeah, I don't know half of you will survive in my regular class, like back in the day. Talk for like every day was like this. All right. I'm going to pause for a second. All right, we got number 4. Let's see what that says. Holy cow. This is a long one. F of x is equal to, it's a piecewise function, x squared plus x when x is less than or equal to 1, okay, 3x minus 1 when x is greater than 1. A, show that f is differentiable at 1. And then after you show that, they want you to find f prime of 1. So, before they want you to find f prime of 1, they want you to show it's differentiable. So what do we have to do to show differentiability? Okay. I heard blah, 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 blah. What do I have to do? Yeah, but what do I have to establish first? Continuous. Okay, continuity. So I'm going to establish, by taking limits, establish continuity. X goes to 1 from the left side, which is x squared plus x. So when you plug in, not, come on, from the left side. Okay. Okay, when I plug in 1, I'm going to get 2. Then I got to take a limit as x goes to 1 from the right side, which I am using 3x minus 1, which turns into 2. So far, so good. I also have to establish what is f of 1. Which one do I use for that? Top one, 1 plus 1, which is 2. I know f of x is now what? Continuous at x is equal to 1. Okay, now I got to find the derivative of this. So f prime of x of the piecewise function. What's the derivative of the top one? 2x plus 1. Bottom one is 3. Okay, x is less than or equal to 1, and x is greater than. I do have to put that domain restriction that goes with it. Okay, what I have to do now again? Limits. Limit as x goes to 1 from the left side, so which is 2x plus 1, that turns into 3. Limit as x goes to 1 from the right side, with 3, which is turns into 3. Okay, and f prime of 1 is 3. So there it is. It's differentiable, and f prime of 1 is 3. Okay. Part B. Find f prime for all x. Yeah, we already did that, didn't we? Here it is. Part C. Show that f is not twice differentiable. What does f is not twice differentiable mean? Second derivative. So we're going to take a second derivative, okay, f double prime of x of this piecewise function. So what's the derivative of that? 2. What's the derivative of that? 0. We can already see it's not twice differentiable, but we have to show it. So how do we show it? Take a limit as x goes to 1 from the left side, which is 2, which is 2. And the limit as x goes to 1 from the right side of 0, which is 0. And then we can say f of x is not, or let's just go a short way. F double prime of x, d and e. Does not exist. Okay. Show the graphs of f and f prime of x. Folks, really? Do I have to graph a parabola for you? Yes? Fine. I'm going to graph this parabola. Okay. First of all, this one can be factored. So my x times x plus 1. That means I have a 0 as my one x-intercept and negative 1 as the other one. And which way does this parabola open? Up. Okay. And it's going to do something like that. But at 1, okay, it becomes 2, right? Okay, so it becomes 2, so it stops right there at 1. Okay, and then to the right of 1, it turns into a what? A line. Okay, this line has what kind of a slope? 3, and then what's my y-intercept in this one, this line? So I'm going to call this negative 1. That's my y-intercept. And 3 means I'm going to go up 3 steps over to the right 1. So I have a line that does this. But this line only exists to the right or left of 1? To the right, so I got to erase this part of this line completely. Can't have that. Okay, so this is a line. Oops. Head eraser. This is a line that looks like that. Okay? But this is a parabola. Okay. Notice we found that f of x is differentiable. Means there's no corner there. So the parabola and the line have same slope. That's why there's no corner. It's a smooth curve. Okay? That's why it doesn't look like, it's change. It doesn't look like it's changing from a line to a curve, or a curve to a line. Okay? Now, that's my function. And my derivative, let's graph the derivative. Okay, what kind of a graph do I graph when I graph the derivative? A line. What's the y-intercept here? 1. What's the slope? Okay, that means I'm going to go up 2 over 1. Okay, and so I have a line, okay, that does this. Okay, but this is the derivative. Okay, this is my f. Let me label this. That's my f prime of x, and this is my f of x. Okay, but this derivative only exists to the left of 1, so that means I have to go over here, erase anything I have to the right of it. Okay, what kind of a, I know lines are straight, what kind of a line do I get for that one? Horizontal. Okay, that means it goes up to 3, and it's a horizontal line. It looks like that. Look, this is the derivative. Does the derivative have a corner? So if the derivative has a corner, does a second derivative exist there then? No. And we verified that because of that. Okay? There it is. That's why second derivative does not exist, because the derivative has a corner. Wow, is this exciting and interesting, Carl? Wow. Yeah, totally. Well, you know what? We can all not take calculus and send all the jobs to my cousins and their kids in India. They'll be happy. They'll do calculus for us. All right, number 11. Section 11. You want me to stop, or you guys act like you're just like dying right now? Okay, let's stop in the middle of this because both 3 and 4 are really long problems. So I'll stop at, I'll do 1, 2, and 3. Which one do you want? 3? If I do 4, I have to rush through 3, okay, and then your eyes are going to glaze over and then crossed, okay, if you're still awake by that time. So I'm going to do 3, I'm going to stop right there, pick up the rest of it tomorrow. How's that? Alright, here we go. 3. To section 11. Y is equal to u squared minus u plus 1 u cubed. All right. Thank you. U cubed. Okay, and then they said u is equal to, okay, 1 minus x, all that over 1 plus x. And then they say calculate dy dx at x is equal to 0. There's 2 ways to do this. You pick your poison, because number 4 is really, number 4 becomes really long. So one way is easier than the other, okay? But I'll show you both ways. Here's the first way. If I take the derivative of this, I am finding dy du, right? dy du is 3u squared minus 1, and you say, oh, that's a piece of cake. When I take the derivative of this, I'm finding du dx, because x is my variable. But I still have to use a quotient rule. So denominator, which is 1 plus x, times the numerator, which is negative 1, minus numerator, which is 1 minus x, times the denominator, which is 1, all that over denominator squared. Clean it up. Algebra. Be careful. Carl. Negative 1 minus x, minus 1 plus x, all that over 1 plus x, quantity squared. X is cancel, negative 2 over 1 plus x, quantity squared. Okay, I'm not finding, this is du dx, this is dy du. They want me to find dy dx. Okay, to find dy dx, all I have to do is take dy du and multiply by du dx. Because du is going to cancel, you're going to get dy dx. Correct? Okay, so let's go ahead and take this, multiply by that. So dy dx turns out to be, okay, dy dx turns out to be 3u squared minus 1 times negative 2 over 1 plus x squared, quantity squared. Only one problem. I got a u sitting there. What do I have to do to get rid of that? I got to write everything in terms of x. So what's my u really stand for? 1 minus x. So I have a 1 minus x over 1 plus x squared minus 1, okay, all that times negative 2 over 1 plus x, quantity squared. Okay, this is my dy dx. Yes. Yeah, that is a 3. Thank you. 3. That is my dy dx. But they want me to evaluate this at 0. I know you'll be tempted to simplify this and then evaluate, but you better do what? Just evaluate it. Okay, as is. So let's plug in a 0, dy dx at x is equal to 0. And we can do that. We're big boys and girls. We can do that in our head. 0 here gives me what on the top? 0 here gives me what on the bottom? What's 1 over 1? Okay, what's squared? 1. What's 1 times 3? 1? 3. What's 3 minus 1? 2. Okay, 1 here, 0 there is going to give me what on the bottom? Square it. 1. What's negative 2 divided by 1? Okay, what's 2 times negative 2? Negative 4. That's one way of doing it. Are you still with me there, Lily, back there? Okay, just doing a hormone check back there. What happened to our little friends back there? Oh, Lobna's gone again? Oh. Alright, I'm going to do the same thing. This time I'm going to do it a little differently. And you get to pick which way you want to do it. I don't really care. Okay? Y is equal to okay, the reason I'm showing you both ways is in some problems, one way is easier than in other problems, another way is a little easier. You'll find in the second problem, it's easier to do it this way. So that's why I'm showing it to you. U to the third minus u plus 1. Okay, u is equal to 1 minus x, all that over 1 plus x. Okay, we're finding dy dx at x is equal to 0. Okay, what you would do is, you would take this and you go ahead and substitute that in. So y now turns into 1 minus x over 1 plus x cubed minus 1 minus x over 1 plus x plus 1. Now it's in terms of x and the y, so I can find dy dx. The only thing is I have to use a chain rule here. Okay, 3, all that times 1 minus x over 1 plus x to the power of 2. Then I got to go inside. Then I have to use the quotient rule. Okay, denominator, which is 1 plus x, times the numerator, which is negative 1, minus numerator, which is 1 minus x, times the denominator, which is 1, all that over denominator squared. That's only this part. Minus, I got this part, but I already did that part. It's right here. So it's going to be 1 plus x times negative 1 plus 1 minus x times 1, all that over 1 plus x quantity squared. Of course, that's 0. Are we good? Alright, again, you'll be tempted to simplify this. But we got, what would you do? Plug it in? Yeah, plug it in as is. Same thing on the AP test. Plug it in as is. Okay? Because it's a lot easier. Alright, here we go. Here comes big numbers. 0 here gives me 1. 0 here gives me 1. 1 over 1 is 1. 1 squared is 1. 1 times 3 is 3. Alright. Here we go. 0 here gives me 1. 1 times negative 1 is negative 1. Okay? Negative 1. Okay, 0 here gives me, okay, 1 times 1 is 1. So negative 1 minus 1. All that over 0 here gives me 1. 1 squared is 1. Okay, and then I'm going to get the same thing in the second one. Okay, so that'll be minus. Okay, so negative 1 minus 1 over 1. Alright, here comes the hard math. Negative 1 minus 1. Negative 2 over 1 is negative 2. Minus negative 2. Okay, so 3 times negative 2 is 6. Okay, plus 2. Yeah. Negative 4. Is that what we got on the last one? I hope so. Yeah. It's up to you. But I think in this next problem, number 4, second way is easier.